Let's see. Let me see if I can get... I'm going to try to get the link for you. Just be aware that, like, anyone here will hear you. So...
Okay.
Let's see. Well, that's cool. I can pop out the chat. All right, do that. Live stream settings. Oh, here it is. Cancel. Share. Copy. All right, sending you the link. And just tell me if you can hear, just a quick audio check, if you can hear me and if you can hear yourself.
How did you send it?
I sent it in the Zoom chat.
Oh, got it. Hello?
Can you hear yourself and can you hear me? Are you in the... Did you hit the link? Are you there?
Yeah. I think I could hear myself. Yes.
You
Yeah.
can? And you can hear me?
I can hear you, yeah.
Cool. So I'm going to blast this out on the Twitter sphere.
Okay.
All right. I think I can minimize that. I think... Hey, look, we got someone in the chat already. How's it going, Antonio? All right. I should have left this window up. What am I looking at here? All right, cool. We've got some people joining. Nice. I do not want to look at the stream delay. That is really, really awful. Okay, that's good to know. Cool. I'm glad people are showing up. All day? Well, I hope it meets with your expectations. Thanks for joining us, Cesar. Appreciate that. All right, so I didn't really have a good way to start this. I want to make sure that the people who want to join us are going to join us, but they'll filter in. Hello, for those of you who don't know, I'm Dan Reynolds. I don't have a webcam hooked up to this computer right now, but you can all just imagine what I look like. I hope so, Aaron. Yeah, this should be available for video later. That's my hope. This is my first time streaming on YouTube Live, and so I am. I'm not sure how it's gonna go. I upgraded my internet, as you do. Hopefully, it will be okay, and it's this possible that YouTube will restrict how long I can stream. I don't know. It seemed to imply that I'm only going to get an hour of streaming. So we'll see. But yeah, the hope is that it will get archived on my channel here. That was why I decided to stream on YouTube, because on Twitch, I think I was only going to get like a week or 2 weeks or something like that. So that's the hope. That's the idea. If it cuts us off, it cuts us off. We'll get as far as we can get. That's the thing. If it's really important, then I might restart it. But we'll see. We'll see. Hopefully, it'll be fine. But yeah, that's the plan. That it will be archived. So I'd like to introduce a friend. He's going to be kind of like a moderator. Oh, I should give you moderation privileges, Justin. I forgot about that.
Okay.
Oh man, I don't really know how to do that. That was something we should have known beforehand. Well, hopefully everyone's going to be amicable. And at least you could tell me, Justin, if someone's acting up. I need to kick him out or something like that.
Okay.
So Justin here is a good friend of mine. We've known each other for a really, really long time. We actually used to teach together. We used to teach video game audio together a long, long time ago. And he's now at Blizzard kicking ass. And so, yeah, I'm really happy he's been able to take some time out of his schedule to help me out with his stream. And the way he's going to be helping out is he's going to be keeping an eye on me. Because I'm probably going to start focusing on what's in front of me, and so it's possible people ask questions that I won't see. It's also possible that he'll have ideas if he's like, oh, did you think of this or whatever. I don't know. It's helpful to have someone sometimes to bounce ideas off of. And then if it's super slow and everyone's like, this is lame, and then leaves, he and I can just, chat or whatever and hang out. So yeah, so that's basically the idea. So, okay. I don't know, Justin, if you wanted to say anything to say hi to people.
Hello.
So I got on my screen is hello. Oh, why did I have that set up? Let's do. Oh, I haven't. Here, we'll do this. All right, I'm going to be using Photoshop as a whiteboard. Oh yeah, that's a good idea, VR Game Zone. I should mention this on the Discord. I think I quit Discord. So someone else will have to forward this. Do you want to do that, VR Game Zone? Do you want to tell people that it's happening? That'd be awesome. Hey Joey, what's up? Joey Curtis in the chat. He worked with me at Epic a little bit ago. He's awesome, man. Justin, you remember at the school we had the sound effects kit that we were able to use because of Tommy. Tommy was on the board of whatevers for the school.
Yeah.
Joey worked on the sound effects kit.
Oh wow.
Joey, that kit was super useful at the school because it was, I think, the only library that we had where all the assets you could just drop into the game engine because they were all edited and ready to go. So that was super useful when we were teaching Unreal and Wise because we could just like we just had the ready, set, edited library to go. The students didn't have to like think about that part of the problem space, which was super helpful. All right. Okay, so what we're about today. Let me see if it's zooming in here. The plan is to talk about we're building an ambient sound system. And so what we want is basically an idea of what are the goals for this sound system. So I think the primary goal we want to satisfy is something basic like an ambient bed manager. And just real briefly, I want to touch on sort of what my philosophy is for an ambient sound, because I think ambient sound is a really important part of the world building process. And the thing that I would like to stress is that we're building a system, and that this system is going to be, if you're building a system on your own project, that system is going to be informed by design choices, and that in turn your design choices will be informed by the system that you make. So it has to be, fundamentally, it's an iterative process. You have to go through the process of iterating between, building something out, fleshing it out, and then putting the content in and implementing with it, and then making decisions about the system, and then that in turn informs how you design your content. And so it could be that that you have that maybe the system that you build ends up changing the way that you want to record your source material, right? That's totally possible. It's possible that it will influence the way that you want to edit your sounds, the way that you want to master your sounds. So all of those sort of decisions are part of like a ecosystem, a feedback system. And so building an ambient sound system is going to be very specific to what your project's needs are, what your project's goals are, and it's going to also be important to take into consideration when in the project pipeline or a timeline that you're building this, right? Because if you have already gone through all the trouble of building assets and sourcing material and all that stuff is edited and you don't have an influence, it's possible that you don't have any more influence on that part of the process. And so your ambient sound system may be sort of obliged to support whatever form that has taken. Ideally, you will have gotten involved as early in development as possible. Preferably something like this would be built during the pre-production phase, when you can go through that iterative process, where you can try things out, where you can say, okay, what if we split up our assets, our ambient sound assets, like this? What if we have like a basic, ambient bed, but then we have a bunch of one-shots playing and that sort of thing. So whatever you build may be different from what we're going to build today, and that's okay. This is not a prescription for how to build an ambient sound system. this is one way to build an ambient sound system. And yeah, so I want to sort of emphasize that. And I will also want to emphasize that because I am not going to go through the whole process of designing a bunch of new assets during this. I have thrown together some, like a folder of assets that I will be pulling from. Some of these are assets that I have cut from sounds that I've purchased personally. And then some of these are stuff that I've recorded and edited. So it's going to be a mix of who knows what. And so whatever we build today is going to be supporting those assets. Whatever you build is going to be something that is specific to your situation. And I want to just make sure that that's very clear. So what I guess before we get too far into it, I should have been much more high level here. What are we talking about when we say an ambient sound system? And the reason I want to define that is because I want to be clear about what it is, what my goals will end up serving, because they may be different from yours. But the way that I like to think about ambient sound is with Bob Ross. So we've got. Did he have like a goatee or something? I forgot.
Yes, he did.
Yeah, he did. Okay, there we go. And then, if any of my students are in the chat, then they will recognize these stick figures. Okay. So this is Bob Ross. He's painting his picture, his painting, and Bob Ross always splits up his painting into 3 layers. He has a background layer, a midground layer, and a foreground layer. So if we were to look at, so his background, he always starts out with these mountains. They're almost always mountains. Whatever. And then he will have some sort of midground, which is usually like a lake or some sort of body of water. But it could just be like it could be a forest or plains or something like that. You get some sort of midground. And then he has his foreground where you get the happy trees and rocks and a bush. And they're happy. So, and this is how he builds out his painting. So, the background layer, the way that I see this division in sound is the background layer is usually our ambient beds. These are like the matte painting. That you would have in the background of a set. No one interacts with them. They just sit there, and because in context they look realistic, and so they work for us. And so these are usually not, and so we could say usually not dynamic. All right, and then our midground, for me, these tend to be one-shots or 3D sounds. Oops, sounds. And these would be like, you know, if we're going to the matte painting in film, then this would be like sets, like bits of, you know, properties on sets. But what's important is that these 2 layers are about world building. Right? We want to flesh the world out. We want to make it feel like it's full of life or whatever it is. Whatever it is. I mean, it could be full of death or whatever. You know, it's your project game or whatever. So, whatever the narrative, it has to serve that, right? But it's not part of the foreground. Foreground, this is like gameplay stuff. This is stuff that's relevant to gameplay. This is me pretending I remember how to spell relevant. Right? So what we're trying to do is primarily this, maybe this if we have time, but not this. We don't care about the happy trees. That is for the designs. That's specifically for the design of whatever's happening, right? So in games, our foreground is usually our character. This is usually our character. Or like it could be NPCs, or like specific diegetic sounds that are fixed in the world or a part specifically of that world. If that makes sense. So what we want to do is basically have a system that manages this stuff right here. That's the goal. Are there any questions about that?
Not as of yet.
Not yet? All right, cool. So with that in mind, let me... do I have this? There we go. Cool. So we're going to put Bob over there for a second. Okay. We're still on the same layer. Good. So then our second goal... Oops, why did I do one? Our second goal will be some kind of one-shot system.
We got a question. Can you give any examples of a one-shot and a 3D sound?
Yeah, that's a good question. So we usually classify sounds in a couple of pairings. So we have 2D sounds versus 3D sounds, and we have one-shots versus looping sounds. So in the context of an ambient sound system, a 2D sound, especially in Unreal, a 2D sound is generally meant for something that is not spatialized, whereas a 3D sound has spatialization. And so when you play a 2D sound on a stereo output in Unreal, both the left and right speaker have the sound in it. And if the sound itself is stereo, then it will be the left channel to the left channel and the right channel to the right channel. There's no balancing that occurs. There's no spatialization of the sound inside the world space. It doesn't pan from left to right. And that's what I mean. So it, like, when we're building our ambient sound system, the mountain range, which is our background layer, will be 2D or 3D sound field. And what this means is that it will not appear to come from any specific direction. The exception is a sound field, which I'm not going to go into a lot of depth, but an example of a sound field is ambisonics, which is a full sphere of sound. And so from the listener perspective, it envelops the listener. But it doesn't come from any specific location. It just has a sense of rotational consistency. So we need these 2D sounds for things like air and room tone. Yes, you could compose air and room tone from a bunch of 3D sounds. Absolutely. But do you need to? Is it important for that particular project or the story or whatever's happening in that particular space? That's a question you have to answer. And answering that question will make you will usually determine whether it's actually a background element or if it's a foreground element that just is not noticeable right away or something people have to locate or discover, right? So like, for example, a fan inside of a room interior could be considered background, right? But if the fan is relevant to the story, then maybe it's not. Could a sound field be compared to a post-processing volume in terms of how they transition? I would not compare them because a post-processing volume is actually a video effect. So it's more post-processing. What the analog to post-processing would be something like a submix effect, where you have like a DSP process that is literally affecting the entire output of the audio. Hey, Arthur. We got Arthur Barther in the chat. Dig Art. Welcome, Arthur Barther. I was showing Justin some of your wacky stuff a while ago. I don't remember when, but Arthur is awesome. He's always got some crazy experiment going on, which is really cool. All right. Did that answer the question? I hope that answered the question.
One shots versus loop, I think.
Oh, right. Yeah. So then we have right, the other classification. See, this is Justin, you're awesome. So the other classification is a sound that is meant to be looped and a sound that is not meant to be looped. So, in the context of our background, a loop might be like any sort of continuous element that needs to run throughout. So, for example, in a painting, in a background painting, that could be like the sky, right? Like the sky is something that runs throughout the painting. It could be broken up by clouds, which means there's variation. But the sense is that it's continuous and infinite and runs off, from both sides of the frame. When you enter the painting or you look at the painting or enter the scene, it's something that's always been there. It's something that will always be there. It's something that's there when you leave. And so that's something that you could sort of analog to a looping sound. So let's say this is a looping sound here. And this is meant to loop back in on itself. And then a one shot is like a single element that would play, but is meant to maybe only play once or maybe only play at some infrequent period. And this could be something like, let's say if this is our air gentle wind, not obvious. And this could be a gust of wind, like an individual gust of wind. Or wind of wind. Right? That could be a one shot. Or this could be a background. The loop could be a background of some forest. And then we could have one shots that are like birds. Bugs. Right? Fauna. So that's how I would treat them differently. A loop is usually what I would consider an ambient bed, and a one shot would be like a single element that plays on top of that ambient bed to create variation. Okay. Is that all good? Everyone get that? I think I'm going to pop this up to a different layer. Oops. Did I not do it a different layer? I did it. Oh, there we go. Boom. Why isn't it moving? Oh, because I'm touching both of them? That's a problem. Ah, it's moving the whole thing. Stop moving both of them. There we go. We'll just make this one invisible. Okay. Goodness. Okay. And then one last thing that I think we want from this system is going to be so we want an ambient bed manager. We want a one-shot system, though I would consider this for today a stretch goal. Ghoul, stretch goal. I would like to make sure we cover this. This is your implementation method. So what that means is you've built a system. How are people going to use it? And so this is where I will talk about data assets. Okay, cool. Very, very nice. All right. Questions before moving on? Group these two together.
I haven't seen any.
Cool.
As of yet.
All right. Oop, there we go. Okay. So let's talk about starting out. There's an eye in there. Strategies. First things first. You're working on a project. Make that sound. Don't wait. We want to make a sound as quickly as possible. So let's get something roughed up. We know we need an ambient bed manager. So let's manage some ambient beds. All right, so where's my Unreal? Here's what I got. I have the third-person template, a project. This is built with 425.1, so it's possible that, you know, something's changed, so just be aware. 425.1. This is, I haven't done anything to this yet. Just move the camera around, I guess. If you play this, it's a little third-person deal. He can run, he can jump, he can go toward the camera, left, right, whatever. The little mannequin. And that's pretty much it. So the reason I want to prototype this, in general, I tend to choose the third-person template to prototype things. The reason I choose the third-person template to prototype is because I used to use the first-person template, but I discovered that the listener, which is by default inside the camera, and the pawn, which is the character, the player controller, it's easy to conflate them. If you're a first person, you end up conflating those, and the problem space is a little more complicated when you're dealing with third person, so it's good to work those out during your prototyping phase. Because if you're working on a project that is third person, and then you've built your stuff in first person, it's possible that you've forgotten something important. So that's why I do this. I choose the third person template almost always. But if you're working on a project that's already got, some sort of gameplay, then use that, obviously. There are some skills that you will want to practice. You want to practice what we call white boxing or gray boxing, sometimes it's called. And that's where you're able to build out a level like this. You want to be able to build a level like this. Nothing special, it's just a bunch of blocks. And these are all sort of predefined blocks. But I have built levels that are just these cubes, and you can totally do that. So that's something that you're going to want to practice. The other thing that we probably won't get into today, but is good to practice, is using and building UMG widgets. UMG is the user interface WYSIWYG editor, and that is a really great way to help prototype. So both of those things, white boxing or gray boxing, and using UMG are really important skills to sort of develop to iterate very quickly inside of Unreal. And really on any project. I mean, it could be any engine. It's just that we're talking about Unreal today. So, okay, so we want a little ambient bed manager, and we don't care about any of this stuff. What we want is to maybe simulate two different places. So what I'm going to do is I'm going to zoom out here. I'm going to click on my floor. I press spacebar to change the transform widget. That's something you want to get used to being able to do. Basically, I'm just going to create a larger space, which will help me simulate moving between multiple environments. And I don't really need a wall here. I don't know why I've got the wall. I'm just moving the wall, whatever. And then maybe we'll add oops. Alt. Hold Alt down. There we go. So we got one section, another section. And we don't need this text. We don't need this little question mark thing. Whatever. The rest of it's fine. Okay. So let's make these bigger. For no good reason. I'll just make them bigger. Okay. Now we've got two places. We can go here and we can go over to this side. So we have some sort of obvious division. So we can test this out. I've also done stuff like made little pads. Excuse me, with the cube on it. And then you just know if you've stepped into a new zone. Okay. So, I have my little prototype materials. Let's bring them in. What do we got? I think this one. Hopefully you can hear it. Hope that looks like a very quiet asset. And let's do. These might be too similar, but we'll see. Okay. Yeah. All right. Yeah, these are different enough. Hopefully they're audible on the stream. Okay, so we'll start with these two sounds. And we want to just get this thing working fast. So what we're going to do is let's create a new sublevel. We'll call this our audio sublevel. We're going to open up the window. We're going to bring up levels. We're going to dock this. Boom. And then we're going to bring our audio level in. We're going to save. We're going to save. So now our original level, which we've modified, which has all this game stuff in it, all this geometry, now has a sublevel, which is audio specific. And this allows us to decouple the geometry with the audio. And this is going to help us in the future. It's going to help us when we're dealing with source control, which is super important. But it also means that I can lay things out in the audio sublevel without dealing with the rest of the geometry. Now, it's possible that we want those coupled, but I found most of the times I want it separate for some reason. So we're just going to do it. And then also, we can put our own audio-specific logic in the blueprints there. So, if I open up the blueprints, edit audio, boom, we've got our level blueprints for our audio sublevel. And what we're going to do is we're just going to keep it super simple. We're going to add a trigger brush, which is just this volume here. And we'll fill our space. Cool. So it encompasses this section, and then we'll make another one by holding Alt and dragging, and then we will I guess what we'll do is have a dead zone. So we'll just have, why not? Why not? There we go. There we go. Looking up. So I would consider all of the skills I'm using right now are not specific to audio. And I think you'll see that throughout most of this, a lot of these skills are going to be just general game design skills. So these are the things that are worth practicing. Okay, so these are, because my audio level was selected, it was blue when I placed, see how the audio is blue on my level thing? Because it was blue, that means that these volumes, that was the active level when I placed these volumes. Which should mean, if I did it right, that when I make the audio sublevel be invisible, we no longer see the volumes. See they disappear? So, that's handy, because what that means is that these volumes belong to the audio sublevel. So the audio sublevel is loaded by the persistent level. And so the persistent level is a reference to this audio sublevel. But the audio sublevel owns the references to these volumes. And that makes it very handy if we're going to use the logic here. Because I can just pull a reference directly from it because it owns that reference. So here, create reference to trigger volume. And if I wanted to, I could name it something respectable. Like we could say, I'm going to double click here and rename this first trigger volume. This will be our forest volume. And actually, let's give it a prefix. We'll do Ambient Sound Manager prefix forest volume. So that way, alphabetically, all of our stuff will be sorted. And then this one will be the mountain air volume. So ASM mountain air. Or mountain volume, I guess. We'll put it, whatever. There we go. And Justin, this Forest Crickets is from our Monrovia session.
Oh, nice.
Yeah, that was a good one.
Those are good sounding crickets.
I don't have the full session. I have to get the full session for you. But
I have it somewhere. I can probably get it to you.
I have like 4 minutes of it or something like that. I think I just picked the best 4 minutes. Because there were a lot of hikers that day. All right. So we've got our volumes are labeled much more sensibly, which is good. And we will set up a new reference here. So we'll click our forest volume. And we go create reference to forest volume. Nice. And actually, in this case, with the forest volume selected in the level, I'm just going to create a simple overlap event. Oops. So we'll do a begin overlap, and we'll do an end overlap. All right, and both of those are in, you can search like I did, overlap, and then just find the spot. You're looking for an event, they look like little arrows, or you'll notice that they're just under collision, boom. And we can optimize these volumes later on by saying what can actually overlap it. But we won't worry about that right now because we're just doing with a prototype. All right, all my windows disappeared. Okay. All my windows. There we go. I got the chat back. Cool. Okay, so we're going to do a little check that this overlap is a physics event, which allows you to evaluate when another piece of geometry overlaps this geometry. And so this actor is the overlapped actor is the forest volume. The other actor is going to be something. We only want it to be influenced by one object, and we'll do our player character for now. This may be influenced by whatever your project's situation is, but it's a good way to filter out the responses. So we're going to branch on that. And I'm going to do a little copy pasta. Boop. Similarly. Boop. Boop. All right. So now it will only get past this branch. It will only be true if the overlapping actor is our player character. Which suggests that we've moved into the volume. Okay, and then what we're going to do is we're going to... we could do a create sound. We'll try this. We'll do... This is very simple. What did our... This is the forest, so... Forest. Alright. And then we'll cache the audio component that this creates. Create sound returns an audio component. Audio component. And this reference is something that we can validate. We can right click and go validated get. So now, if we leave, if we walk out of the volume and this is valid, then we will stop. Oh, I forgot. We'll play this. Play. Okay. So there's some basic functionality, and we'll test it. This is the left one. Okay. So, and we'll get our stat sounds up just so we can see if something starts playing. Oh, it did not. So then we gotta check. What do we do wrong? I will put a I'll hit F9, and that will put a breakpoint in the blueprints. And what that means is that when this overlaps, it will hit this branch, and then it will stop the execution of the game, and then I will be able to evaluate what's happening in here. So hit play. All right, it's possible that we don't have a valid player character. All right. So let's actually nothing's let's double check our volume properties to make sure that we are generating overlap events. So we're generating overlap events. We don't want the character to. We do want it to trigger. What's this? During level streaming? No, we don't. No, that should all be fine. I don't think we care about hit events. This should be good. So these look good. It's possible I just didn't. Maybe I just didn't save it. Let's save it. There we go. Let's try that. Nope. All right. Let's see. I'm not even hitting this branch. Let's make sure that we've got... we are ticking. That's good. Let's... Let's make sure this is valid. So let's make sure that this is even a valid object. So we're going to just print if it's true. We don't need this branch. Okay. I just want to see if... Boop. Wow, we didn't even get that. So... It's possible that I have not... Okay, let's make sure that my audio level is even streaming in. That's probably our problem. Okay. Begin. Whoops. Begin. Play. Stream. I think this should do it. Okay. There we go. Good. That's what we get for making it complicated right from the start. So, for quick review, because I made this a sub-level, I forgot to stream it in first, and that's it. And so now I'm streaming it in. But that's something to keep in mind when you're prototyping, depending on, you know, how much time you have. So now, if I go, boop, 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 maybe we'll hit our breakpoint. Oh, we've just got play. Good. I must have taken the breakpoint off. All right. And will it stop it? It stops it. Look at that. Functionality. It works. Okay. Now that's really, you know, super abrupt. So let's, we're good with this. We don't need to, we now know this is loading. So we're good here. My breakpoint wasn't getting hit. But that's fine. Okay, now what we're going to do is we're going to, instead of playing it, we're going to fade in. And we'll give it, I don't know, what do you think, a second? We'll give it a second. And then instead of stopping, we will fade out. And we'll give it an equivalent second. And let's go with equal power. Why not? There we go. Okay, so this will fade into 1. It will fade out to 0. Good. Now, we play. We cross over the threshold. Nice. Fades out. Very nice. Okay. All right. So we've got some basic functionality. Let's get the other one set up. Now, this is where we have an interesting choice. Because we have... we could keep doing this, right? Like, I could get a reference to my other volume. Right? I could add my, my overlap event. I could add my end event. We could go through the same logic. Copy, paste. Boom. And then we just swap this out for the mountain loop, which we have not actually looped yet, but we'll get to that. And the mountain loop, let's see, will it play right away? I think we need to make sure that it's during stream as well, but we can touch on that later. It should be like this. Oh, we killed it. Ah, yes. So here we have to also make sure that we are caching this to a different reference, right? So we want to make sure this is our mountain audio component. Boom, boom. Oh, this is set. Good. Validated. Boom. 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 Okay. Okay. Now we cross over. We've got forest. We've got mountain. They switch off. That's the behavior that we want, generally speaking. And, you know, those fades could probably be finessed somewhat. But the behavior is there. But, you know, this is not sustainable. This works, but it's not sustainable if it doesn't scale. Because, you know, what are we going to keep doing? We're going to just, you know, how many of these zones will we have? Will just be like a whole thing of each individual zone? No, we don't want that. That is not going to be, that's not good. So let's take a look at what we're going to need to deal with, right? So first of all, we don't want to have to list every single volume, right? Let's go back to our, oops, I lost everything here again. There's the chat. Where's place? Oh, there we go. Okay, make that sound. This is what my boss calls make a sound. I should have mentioned that. Give him credit. He calls it the make a sound pass, and he learned that from his old boss, Don Vecca, from Sledgehammer. And this is just about getting the sound working as quickly as possible. And the reason is because it's going to give us a lot of information. Even though it's not something that we're going to end up keeping, it's going to give us information. And so we see that we have a whole bunch of needs. So let me just go off to the side here and talk about, let's see if we can make a list of what we need to deal with. So we know that we're going to have some kind of why do I put or? Of manager, possibly several, but we know at least we need some kind of management blueprint, some sort of script. Let's put script there. Okay, we know that we're going to have to scale with many volumes or triggers, right? Some kind of trigger volume thing. We know we're going to have to do that, and we're going to have to, it has to be scalable. This is really important. It's got to scale somehow. And then we also, we don't, and what I mean scale is like, before I get onto that one, what I mean by scale is that it's going to have to, I don't want to have to add an event for every single volume. I want that to be automatic. So some sort of like automatic way of dealing with new volumes. Right? That way, because like when my team is using this, they want to just be able to place a volume in this level, and then maybe set some data on it, you know, and then that's it. Everything else should be handled. Then the other thing that we noticed is that was not going to be sustainable is all of the audio components we're going to have to deal with. So why do we have to deal with audio components at all? Right now, the way that it works in Unreal is that an audio component is the only way our handle. The audio component is the only way that we have to access and control audio that's already playing. So if there's playing audio, if it's playing using an audio component, then we can stop it, we can move it, we can change its volume or its pitch or whatever. We can do things to it. But if we don't have an audio component, then we have no way of doing that after we've played it, because it's like a fire and forget. And so audio component, as we noticed right away, that I had to have multiple audio component references, and they all had to be different from each other, right? Because I wanted to have that overlapping fade ability. And so we're going to need some sort of audio component pool management. Some way of dealing with audio components. Now that could just be a function of this. It could just be that that's something that, it's possible that that's just part of this management script. It depends. It could be general purpose enough that we just want to use it anyway. So these are obvious needs based on our make a sound pass. We need to build these kinds of things. All right, how are we on time? 2 o'clock. Is the stream still running?
It seems to be.
It seems to be running? Good. Oh, good. They gave me another hour. I don't know why they give me a countdown clock. It's so weird. Okay. I need to get a drink of water. And so this hour in, it might be a good little opportunity for us to take a 5-minute break. How do you feel about that, Justin?
It's fine with me.
Cool. Then I will switch over to the fancy break screen. Even though people will still be able to hear us. And everyone can take a 5, and then we'll be back in about that much time. All right. Let's catch up with the chat. We got Vlad in the chat. Cool. Very cool. All right. You there, Justin? Uh-oh.
Yep.
Cool. Yeah, it's been a long time since the lecture days.
Yeah.
That I forgot to get some water ready. Okay. All right. So, where were we? We know we need some kind of high-level manager script. We know we want an audio component pool management, some sort of manager to handle that. I think, especially in terms of bed management, in this case, we're really talking about our bed management, and because you know, the audio engine itself is already has audio component management. What we're talking about is really the bed management, and the reason is because we want to be able to. There's a couple of transitions when we're transitioning from one state to another. We want to add new audio components. We want to remove old audio components, and we want to keep new, we'll just say renewed renewed audio components. So it's possible, what, you know, we talk about, like, the way that we had our prototype is we just had one looping sound, and then we just faded in another looping sound and faded out the old looping sound. But it's possible that our sound designers, you know, whoever our teammates are, that they will want to have multiple layers to their background. That's totally possible. So we want to support that. But so that means so when they enter a new zone, they have to get information about what new audio components need to be added, what new sounds need to play. And then we want to remove any of the ones that are not part of the new state. But we want to keep the ones that are part of that new state, because it's possible, you can imagine, let's say you've got two zones, and in zone, let's say in zone 1 and 2, in zone 1 you have like a air, like just background air as one of your beds, and then you have some sort of, I don't know, maybe a gentle wind layer or something like that, you know? And then in zone 2, you still want to keep the air playing. So you don't want to fade out air and then fade in some new air. You've already got, if you're moving from 1 to 2, you've already got air playing. There's no reason to stop it, right? So this is that third situation where we want to keep a sound that is part of the new zone that we're already playing. So we need to know. So basically, this manager is allowing us to keep everything singleton. What's sometimes, it allows us to treat sounds as though they're singleton, our ambient beds. So that way this allows us to do sort of more interesting things where we could potentially do something where it's like a zone within a zone, right? And so in this case 1 and 2, and when they go in here, they have not left 1, right? We're just adding 2. And that's a compelling scenario. So it's important to whiteboard out, in this case, grayboard, out your ideas and the kinds of things you want to support, and to try to like think about what are the use cases. Okay, so I feel like this is going to be like the heart of our ambient bed manager, essentially. So we've got some sort of high-level management script. That management script could be, if we look at our old layers, we had the ambient sound manager and the one-shot manager. The high-level manager script could be both of those, right? But this is going to be dealing with the ambient beds specifically. So that feels like the first thing we want to tackle. Now, the other things that we talked about is, how is that information communicated to the ambient sort of bed management system? And that's going to be through this script. This is going to be like the head honcho. And so our volume scripts will somehow communicate to this. But we also want to support maybe just a general blueprint API, so blueprints. So not just volumes, but blueprints. And what's powerful about starting here is that we can essentially use this for our prototyping phase as well. So so we don't have to deal with this right away. What we can do is going off the existing prototype we've already built. Instead of manually playing and spawning audio components and fading in audio components and then manually fading them out, instead we're going to replace that with this blueprint API that's going to be part of our management script, our top management script. And that's going to be like, hey, that will let us work out, how this ambient bed manager is going to metabolize that data. How is it going to ingest that data? What is that data going to look like? And so we'll be able to sort of deal with these, we'll be able to deal with the volume problem and the manager and the script problem as like separate. Because once we have the blueprint API, and the API is just a programming it's what we call an interface, but it's basically just the way that you interact with that object, right? So the manager is going to be an object. The top, our little ambient management system, ambient sound manager, whatever, is going to be that object, that top object. And we want to be able to interact with it with blueprints. And when we can do that, then our commands, our commands could come from anywhere, right? They could come from other scripts. They could come from custom actors that we've built that are volume actors. They could come from other places in our design that we hadn't thought of. Maybe a sequencer event blueprint. Like that could be a whole new place that we could be interacting with that. So if I was coding this manager, if I was coding this manager in C++, I would be making this a game instance subsystem. But I'm not coding, and there's currently no way to create subsystems in blueprints. So what we're going to do is we're going to try to build this off of game instance. We want to make sure that this manager object is instantiated and owned by the game instance, and that will allow us to access the manager from kind of anywhere in the engine. So, all right, so let's look at our, where were we at? Let's see where we're at. Okay. Okie doke. So we need to, let's look at this the world details. I'm more curious. What are the world settings here? I want to see what we have for this persistent level. Actually, let's make that the current level. And I wanted to see what was under here. Game mode, none. Okay, so I think we're just using our default. Is there an existing does it not have a filter? Blendables. Okay. Well, I think we can do this from our project settings. So let's go to our maps and modes. Game instance class. Yeah, so we just want to swap this game instance class for maybe our own game instance class in this case because we're just prototyping. But if you've got a project, then you'll just go off of whatever your project's game instance is. So let's make a game instance for our prototype. We're going to make a custom game instance. So we're going to do a new blueprint class and game instance. Ooh, platform game instance. I wonder if this is that I think we're just using the top level game instance. So we'll base it off of this. This is basically the hierarchy. So we got UObject and then game instance. And so whatever we create here will be based off of game instance. And so we should be able to swap it out pretty easily. So let's do that. So we'll say this is our prototype game instance. I'm going to save this. And it should be there. So now we'll select that. This is now our project's game instance, is this game instance. So what we're going to do is we're going to have the game instance be responsible for, I think we've got some events. Let's see what we've got for events. So we've got on initialization and on shutdown. Those are going to be our most important events. We could potentially manage our level streaming from here, but what is Vlad saying?
He's asking, would the singleton thing work with the new programming subsystem feature?
Yeah. So if you were, a programmer, I would put this manager, this high-level manager, I'd actually make it be a game a U game instance subsystem or a U world subsystem, something like that. I like the game instance because it's something that almost anyone can reference, and there's definitely a call for being able to do that. But yeah, so that's a good question. It's going to depend on how we interact. But I think a game instance subsystem would be the way to go. Yeah, and for anyone who doesn't know what the subsystems, this is basically new. I think it's a couple versions ago that it came out. And what it is basically it allows you to manage the lifetimes of particular systems. So if I created a game instance subsystem for my ambient sound manager, then what that would mean is anytime the game instance is instantiated, it would also initialize my game instance subsystem. And so you would like get that the lifetime management of your subsystem essentially for free, which is really cool. And then it would act like a singleton, and it would be something that you could reference, wherever its game instance reference is valid. So it's definitely the way that I would approach this were I coding this, but I'm not. And so from the blueprint perspective, we're just going to we're going to take our game instance and then we're going to modify it. We're just going to add some basic audio functionality to set up our manager and then hold our manager and then, maybe kill it on teardown or whatever we need to do. I think we're probably fine. Most of what we're going to be dealing with is U objects, and U objects are what are called managed. And so the garbage collector inside of Unreal is every once in a while says, hey, are there any U objects that I need to destroy? And if there are U objects that are lingering inside memory that don't have a reference, then they will get destroyed. And so usually all we need to do to clean up, quote unquote, clean up our U object based objects, we just have to null out any reference that we have to them. And that's really easy to do. And so, and then within some amount of seconds, the garbage collector will notice it, and then it will clean it up for us. And blueprints, we take advantage of this all the time, because blueprints doesn't have to deal with things like initializing memory and then cleaning up after itself, because because all the blueprints are based off of U objects, and so once a blueprint's cleaned up, then anything it was referencing is now open season for the garbage collector. All right. Okay, so we're going to keep this. I like to try to keep my management objects as simple as possible, but I may run into some restrictions. We'll see. So I'm going to create a new object that is literally just based off of object. I'm not going to select anything else. This is going to be the simplest blueprint object that we can create. But that means that it's not going to have things that might be very convenient, and so that's something that we might have to take into account. It's possible that an actor ends up being something we'd prefer for a manager, but if we can get away without it, we'll try it. So let's try to see if we can just do this with a regular object. I'm going to call this my Ambient Sound Manager. Boom. Now we've got an Ambient Sound Manager. I'm going to open it up. And I'm going to add a function, which I'm just going to call initialize. And I'm going to make sure that it's public. And this is where we think about maybe how we want to interact with this, but it's not a deal breaker. So we'll just do initialize if that needs to be called for any reason. It's possible that we could call it ourselves internally, because we do have some events. I believe. Do we have begin? We don't. Okay. So we'll have to make those. So initialize will be a good way for us to make sure that our game instance is using our so that basically the game instance will call initialize on a new ambient sound manager, and then it will do its thing, and then we'll do whatever we need to do when it first starts. So we'll just save that for now. I'm going to go back to my game instance. If you see this, if you this is in Blueprint world. If you open up a blueprint and you don't add anything to its graph, and then you close it and open it up again, it thinks you're using it as a data blueprint. Don't worry about that. If you see this, just hit Open Blueprint Editor and you're good. You can go back. So what we're going to do is we're going to create, I think we have, what do we got? Init? Initialize? We've got, I forgot what our events were. On initialization. Okay, so let's do a quick test. We'll just do a little print string, and I'll watch the output log just in case, so that we can, when we hit play, we just want to see if we get that. We got hello. It's good. Cool. So we verified that this is called when we hit begin play. We've got some overrideable functions. Let's see what we've got. Not worried about that. Right. These are all the events. Cool. So we need to construct a new object from class. This object is going to be based off of our Ambient Sound Manager. And then we're going to give it an outer. And I'm going to select this. This is basically saying like who's owning it essentially, and then we'll cache the reference. This is our Ambient Sound Manager. Boom. Cool. So now we've got an Ambient Sound Manager, and we want to call initialize on it. There we go. Right, this is the function that we created. So now we'll do our test real quick. Initialize. Now we're going to print. We'll say Ambient Sound Manager initialized. And we hit play. There it is. Our text, Ambient Sound Manager initialized. Cool. So now we know. So let's just review real quick. We created a new Ambient Sound Manager object. We created a subclass of our prototype game, our game instance, but there was nothing in the game instance, so we don't have to worry about. I mean, you know, we're fine there. But if you're working on your own project, you wouldn't do this. You would use whatever game instance is appropriate for your project. And then in our game instance, we've just added some code, and we can put a comment around this. It's like constructing our ambient sound manager. All right. That way, anyone else working, because the game instance is going to be something that a lot of people will see. You know, other designers on your project will be using or interacting with. And so this is a opportunity to communicate to them what this code is about. Why is it there, and why are they seeing it? And usually, what you see on these, you know, in a project that's been around for a while, is there'll be some huge sequence node here that goes and like initializes like a dozen different systems. So don't feel like you're going to be the only one here. You're not. This is a shared space, and you need to make sure that you're communicating what you're doing to your team. Okay. So now the only thing we want to make sure is that every time we try to do something with this, we validate it. But we do want to make sure that people can reference it. So let's double check that by going into our audio sublevel. Boop. And getting the game instance. Get game instance. And this is where it gets handy. This is why we want to use the game instance, because this function right here is something that I can call all over the place. And so wherever I need to try to interact with our Ambient Sound Manager, get Ambient So it can't see it. We want to make sure that it's visible. So that may mean that we need to make it public, right? So let's go to our game instance, and we're going to make it public. Boom. Now it's public. This is dangerous. You have to remember this. This is dangerous. Making this public means other people can mess around with this reference. But hopefully they won't. Hopefully the people on your team are cooperating. But what that means is you will want to validate this every single time. You can't count on it being valid. So going back to our audio sublevel script. Now can we get it? Get game. Oops, what did I call it? Ambience. Oh my goodness. Okay. Let's try. Am I forgetting something? I should be able to pull that. Maybe not. What am I missing? Boop, 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 boop. No, that's fine. Jip, jip. I may have to create an API, which actually is safer, but yeah, we'll see. I just want to see if I can get it directly. Sound manager. Oop. Prototype. Oh, that's why. I bet you someone in the chat got that. Because I have to cast the game instance to my prototype class. Boop. Sorry, not class. All right. Then we should be able to get it. Get no? Do I still have to do it? Ambient Sound Manager. The class is right. Okay, so this is going to be our little code path for accessing our Ambient Sound Manager. Yeah, Vlad got it. Vlad got it. Keeping me honest. And that's good to talk about. This is returning the general top-level game instance object reference. It's not... The type is like this, the top parent class. But we're trying to access a data that's on a specific class type. That's our prototype class. So we had to cast it to our prototype. And this is another reason why subsystems are super convenient, because you don't have to do that. You're just like, give me the subsystem, and it gives you that. All right. And this is good to have a. It's probably good to have a some sort of warning if this fails. Because you know, it's if someone changes the game instance class type on us, we would want to have some sort of heads up. Okay, so now we can call functions we don't want to call initialize. We could, but we're going to want to create some sort of a set of functions that we can call on it to do whatever we need to do. And they're probably going to be stuff like set new state or set new whatever. Here are the incoming. Here's the incoming data. Here's the outgoing data. Something like that, right? Okay. Some sort of add, some sort of remove. In which case, because when I think about our scenarios here, we add new, we remove old, right? I think what's going to happen is, because this is what we're talking about right now. We're talking about this top level deal. And I think what we're going to want is it's going to retain whatever sort of current data state it's in. And then it's just going to have to break that data apart for our little ambient bed manager, because that data is going to be like a little data bundle. We're going to want some sort of data bundle that we send to the ambient sound manager, and that data bundle is something that the ambient sound manager is going to have to split up and then divvy out to its various systems. And right now, our top priority is the ambient bed manager. So we want to make sure that we adhere to this functionality. We want to be able to keep, this is the hard one, we want to be able to keep the ones that we don't want to kick out, basically. So we're going to be asking it to kick out stuff, and possibly asking it to add new stuff, but we want to be able to keep stuff just in case. So we're going to need some sort of like set state. This is for the ambient sound manager. Set state, maybe some sort of clear state. The question is, do we want it to be additive? Should it be like add state and remove state? Or are we only adding and removal is automatic? I think that's going to be easier, as long as we have the ability to clear state when we need to. If we're only adding state, I'm trying to work out if there's any sort of obvious issue with only adding state and never removing state, but having the ability to clear state. Because removal would then be implied. This is sort of dangerous, is you have explicit and implicit state. And explicit state tends to be more complicated to implement, but it tends to there's no question of what's meant. Implicit state means that the state is something that is only apparent through analysis, but it makes assumptions, and implementation tends to be more contextual. So if we have if we have add state, or it's just set state, right? Like it's set state. It's one of these situations. We either have add and remove, or we have set. And I guess this comes down to this situation here, right? Like I guess in the sort of nested zones scenario, I can see an argument actually for both. This is, I think we should try to, for now, we'll keep it simple. So we'll nix this idea of this nested zones for now. This is what I'm talking about in terms of like your project will influence the design of this system. This is why a turnkey system doesn't necessarily work, because it's going to make generalizations about what you want as a feature set, and what you want as a feature set is influenced by the needs of your project. So in this case, we're going to, and especially because of time, especially since I don't know if Justin has past 3, so he might have to duck out. So I think we'll shoot for this example first, which is assuming that state is like a singleton, and we'll go with set state and we'll skip the add or remove state. So we'll make it set and clear for now. And then, yeah, we'll see if there's any problems arise from that. Okay. Where are we at? Okay, so we know if we look at our ambient sound manager, we're going to want a function for set ambient sound state, clear ambient sound state. Okay. And then the question becomes: do I want to do the ambient bed management inside this object or inside of a separate object? I think we'll just. I think we'll do it here. Probably better to do it separately, but I'm not sure if we'll get past that. So we'll see. But I'll start with this. Okay, so we've got set and clear, and I want to have a data bundle. So I'm going to create a new blueprint class that's based off of a data asset, the primary data assets type, and we'll call this ambient sound data. We're not getting real creative with names right now. And we'll start with, we'll give it a variable that is actually, let's do this. We will, we'll actually create a blueprint struct. I like this. I like where this is going. We'll create a blueprint structure. We're going to call it struct. We are not getting creative. You can call it whatever you want. Just make sure you know what it is underneath. Okay, and then this ambient sound struct is going to be comprised of a sound base object reference. Now this is an important distinction. There's sound waves, and there's sound cues, and there's dialogue waves. I forget, because I never use them. Sound base is the parent class, which means that within this, sound cues and sound waves are both available. From a design perspective, what you want to think about is what kind of sound types is your team going to use? What do they need? And I would push for a more general use case as much as possible. So in this case, I'm going to use sound base, and I'm going to allow whoever's going to use this to use either sound cues or sound waves as they see fit. And so we'll call this our ambient sound bed. Oh, that's one way I could distinguish the name of the structure. Ambient sound bed structure. We'll call this ambient sound bed. That's what we'll call it. Nice. The ambient sound, and then we'll just call this ambient sound, the actual sound itself. And then I want to give it some behavior. We could do... Let's start with fade in and fade out. And with these, it's actually not a bad idea to add tooltips, especially if you're working with a team, where you can say, the ambient sound bed, the actual ambient sound to play, fade in time in seconds, fade out time in seconds. And this way, when your when your team is looking at this struct, they will get this information somewhere. Maybe not here. They should be on the tooltips when you hover over them. Let's see. So we fade in, fade out. We could have spatialization. This is where I was talking about if you wanted to support ambisonics. Supporting ambisonics. If you want to support ambisonic sound beds, you'll want to add transformation data. And you'll want to make sure that it's a spatialized sound. So that means let's see. The other thing that we'll want is, do we want to have any references to owners? So we're going to be making these in UObjects. UObjects, audio components, when you create audio components, you'll want to give them some sort of, they'll need basically a world context. That's really what they should have, but I think they're going to want to be attached to something. We'll have to look at the construct when we add an audio component. I forget exactly off the top of my head, but I know it'll want some sort of object reference that is, it's not going to suffice that it's the object itself. Like our manager is not going to be, I think it wants an actor or a level, because an audio component is a scene component. And so we may need to have some sort of reference to an owner. And I'm trying to think if we want to retain that inside this data bundle. But for now, we'll keep this simple, and we can add to it later on if we need to. All right. We'll go to our variables, and we're going to add a ambient sound bed. Beds? I guess we'll say beds. And then this is going to be made up of ambient sound beds. But this data is going to be an array. So now what that means is when we create, so what am I doing? So this data asset, what are data assets? Data assets are basically custom presets that you create as a designer. And what I want is essentially a custom preset for all of my ambient bed zones or whatever, right? So I have, in this case, I have my two zones, right? I've got my forest zone and my mountain zone or whatever. And so I want to make sure that there's basically a preset that is created for the forest zone and a preset that is created for the mountain zone. And the reason we do that is because for our sound designers, the people on our team, we will be able to essentially make it so that their implementation method, this is what we talked about, right? We talked about our implementation method, designing an implementation method. The implementation method will be that someone says, okay, I need to create a new ambient sound bed or ambient sound preset. And they'll go to data asset picker, and they'll pick an ambient sound data type. And then we'll call this our forest preset. All right. And when we open that up, it's going to be our data. It's going to be an array of sound beds that we want to play when this preset is set, essentially, right? And this is going to be the data that we're sending to our manager. And so what's cool about this is from the sound designer's perspective, if like you've got someone on your team who's not as into scripting or whatever, then they can just, all they have to do is maybe drop an actor in the level and then set this as the preset on the actor. And then boom, it just works. That's what we want. That's what we want from functionality. So we've created a preset. We want to make another one. I just hit Command W, and we're going to call our mountain preset, right? So we've got our two presets. And we know what data we want in them already, right? So in my forest preset, I'm adding an element to the array. I'm going to put my crickets in there. I'm going to make sure my crickets loop, which I haven't checked. So let's make sure that loops, loop, making a loop in it. Boom, loop. And then I want to be able to customize how long it takes to fade in, how long it takes to fade out, right? So we'll do, let's say I want the because it's possible that different types of sounds will have a different, a different fade in and fade out setting that works for that particular sound, whatever the sound is. Like, so like a slow fade in might be appropriate, whereas maybe a fast fade out is appropriate for the particular sound. And so, so that's some, the other, this could also be part of the API. If you feel that these are contextual, like you want slower fade-ins, slower fade-outs based off of things happening inside the game, then that could be, instead of being on here, it could be part of the actual call, the function call, like set the new ambient sound bed. But this allows me to change the fade-in on every individual bed. And so that's something to think about. It could also be that that we use like a fade scale. So instead of having it the time in seconds, it could be like a scalar. So whatever fade time was for the new setting, that this would be like half as long or twice as long, right? That could be an interesting way to approach it as well. So there's a lot of different options, a lot of different things that you could consider. And that's all going to be dependent upon, what is going to work for your project. This is another reason why, turnkey systems don't really work as well, because all of these questions that come up and then we have to answer, every time we answer one of those questions, some route of possibility is closed off to us. It's the Robert Frost 2 roads, right? And we can take one path, and when we do that, we don't take the other path. That the rejection is implied, but it's there. And so you're not necessarily going to be able to cover all the bases. You want to make sure that you're covering the bases that matter. Yeah, Vlad, you totally can make... So Vlad is asking, I wonder if we can make a procedural seamless loop system where we get more mileage out of a few sounds. Absolutely. And that's a whole... Well, I don't even think you need the time synth. There's no beat synchronicity that would necessarily be needed for the time synth, but you could absolutely imagine, a string of long ambient sounds that are randomly or procedurally built, and some of that stuff you can actually do in sound cues. And so, this is something that we didn't really, I didn't go into any depth about, but because I selected sound base here, it means the user, the sound designer, could use a sound cue. And that sound cue could just be triggering over and over again some random set of sounds that act like a loop, but are in fact not a looping. Okay. All right, so here's our little data bundle. And then we want to make our... Oh, I forgot. I want it on our forest. Let's do we'll do the 1 second fade in. And we'll do a 2 second fade out. Why not? We can make it different. That's fun. Then our ambient, our mountain air. Let's make sure that's looping. And I didn't check these loops real carefully, so They could be bad. I don't know. Uh, and we'll say this is a 2-second fade in and a 1-second fade out. So there's nice symmetry there. But that's not important. It's just the fact that it's different is cool. Okay, we want to be able to support that. How are we doing on time? We're already 2 hours into the stream. We have a pretty good crew. It looks like always at least a dozen people in here. That's neat. Oh, Aaron's here. That would be the domain of TimeSynth. It's not production ready, but you can do it. What? I'm not sure the context of that. I don't think you need a TimeSynth for seamless looping. If you have multiple sounds, all you really need to do is make sure that there is some sort of fade, crossfading that's occurring, and that doesn't. We don't. I think we could cheat that in sound cues. So I think that'd be the way to go. But that's something to explore. I don't know. Yeah, I mean, yeah, I guess you could do it with the TimeSynth. It'd be interesting. Anyway, you also could just do it with blueprints, right? Yeah, it is a holiday. That's true. I hope everyone has had a satisfying weekend. Okay. Where was I? We've got right. Now we have our bundle. So we want to make sure that our functions intake that bundle. So we will say preset in ambient sound data. It's a data reference. All right. And if we look at that, we'll get a preset in. And then we can actually just get the array directly off of our data asset. And we can do a little check. We want to make sure there's actually data on there. Let's see. So let's do length greater than 0. I'm going to do length. I think because I want to use length again. All right, let's work out what we need to do here. We need. Where's my Photoshop? Okay. All right. So we know the basic functionality that we need, right? We outlined it before. We want to be able to add, we want to be able to remove, and we want to be able to keep. So we're going to need to retain, we're basically going to, first we'll need to cache new state. We may even want to have knowledge of the old state. Because we're gonna need to compare and contrast we're going to want to be able to compare and contrast the new state with the old state, right? Because we need to know what we're leaving behind because we're not going to remove everything. We're going to keep some stuff, right? Potentially. And we're going to need to know all the new stuff we're adding, and we're going to need to know the stuff we need to remove. So we've got 3 buckets, basically. And the only way we can know these, but what's in these buckets, are by comparing and contrasting the new state and the old state. So we need to have both of them at once. So we're going to need to have, going back to my sound manager, we're going to need, we could call it current and old, or we could call it new and current. But I like the idea that current is something that we set. And because set is sort of proactive, we'll do current and old. Current preset, and this is going to be our ambient sound data reference. And these will absolutely be private. We do not want anyone else touching these. So we'll just click that private button. And then we're going to duplicate this. And this is going to be our old preset. So what's going to happen is when we're setting the ambient sound state, we're going to maybe it's not holding the old preset. Maybe it's just holding the old set of sounds. We may not need to actually hold the preset itself. Really, what we're after is just what were the current sounds. So let's talk about that data. So we're going to have touch off. All right, so we're going to have some kind of map where the key values are our sounds, and sorry, why did I say key values? Our values, our keys, will be the sounds themselves, sound references, and our values will be our audio components. And then what we will want is really we will want current set or map, and then we'll want old map. Yeah, so what we're going to want to do, because what's going to happen is the current, okay, so we'll want, okay, yeah, so this is what we want. We want 2 maps. We want a current map and an old map. And the way that we're going to want to do it is when we're adding, we are activating or whatever the new audio components, right? So in order to add to the current map, there will need to be an audio component, a valid audio component, right? So the process of adding will actually add new audio components. So what we want to do is probably something where our first step is going to be. This is where, by the way, a coder is going to have a library of algorithms and code forms that they have done this sort of thing many times before, so it's good to whiteboard this if this is something new for you, or if you're just trying to figure out what's happening. Write it down. Don't have, organize your thoughts. That's the best way to do this. Okay, so what we're gonna do is we're gonna take our current map and dump it into our old map. And then we're going to reconstruct the current map. By checking if while we're adding, we're going to check to see if the incoming sound is already playing, if it already is part of this map. And if it's not, then we add it to the current map. And if it is, then we remove it from the old map. Let's see, we should write this down. So 3, so this, I guess this is a concept. I don't know, reconstruct current map. That's not very helpful. So let's do this. Let's label it differently. Let's say on add, check old, and then it's either new or keep, right? Oops. And so either we're going to be adding a new sound to our current map, or we're going to be pulling an old sound to the current map, back to the current map, basically. And then we will be removing from old. So then these will fade out at their individual timings, and we'll auto destroy the AC. So we'll make sure that this is checked as true, so that that the audio component cleans itself up after it's faded out, because we're done with that sound. Okay. All right. So let's see. What was I doing? Current map to old map. Right. So we're gonna create a current map. We're gonna create an old map. We're going to dump the current map into the old map, and then we're going to start adding. And what we do is we'll take it from the top of the list, and we'll go, okay, just go down, and we'll go, is this sound already part of the old set? And if it's part of the old set, we're going to move that back to the current map. And if it's not part of the old set, then we'll add it in as a new one. Does this make sense to everyone? Are there questions? This is like, this is a script right here. This is why it's called a script. Like, you can think of actors get a script, right? These are the lines and they go in this order, right? This is why we call it a script. It's literally just a set of instructions. And so it's good for you to work out a script like this, to just write it out. Okay. Okay, so we may want to keep the current preset, but we don't need to keep the old preset. We're done with that old preset. And this is going to help us with memory down the line, although we're not really super concerned with that right now. What we want to create are a couple of maps. So the first map we will create is our current map. And this is also going to be private. And this is going to be a sound base reference, object reference. We're going to turn it into a map. That's down here. And then, so the sound base reference is going to be the key. And we're going to put an audio component object reference as the value. Uh-oh. That's scary when I hit compile and it takes that long to compile. All right. Not too bad. Always send. Please send that. We'll see what happened.
Did it crash?
Yeah, it crashed.
Okay.
It's probably something like I had something open at that time. It might not. It might be something weird about the map. So we'll just, yeah, so there might be something. So there might be something wrong with maps. I will hide it in a struct. So we'll try this. We'll try putting it in a struct. Might be something funky about maps. We'll try stuffing it in a struct right now, but that's for some other team to deal with. We'll see if we can stuff it in a struct. We'll do ambient bed map. Well, I didn't need to capitalize that. Map. All right, let's see. And if it doesn't work, I can use this. So if there's something funky with structs with maps right now, I can create my own map with this struct. So hopefully that's not the case, but if it is, it's not the end of the world. Okay, where was I? Right. Let's see if we can just make a map. Sound map. Sound base as the key. It's a map type. So this had no problem. And then we will make the value an audio component. Object reference. See, something funky about the maps in that object. I don't know why, but we can work around it. We have the power. So now instead, this is going to be my ambient sound map. What did I call it? Ambient bed map. That's what I called it. Okay, current map. Uh-oh. Oh my goodness. Yeah. Could be, well, when you think about this, could be something to do with, could be something to do with audio components inside of a U object. Let's see. Add audio. Oops. Component. I think. Let's see if I just promote this to variable. Yeah, that was fine. I am not sure. It was fine with that parameter. So something funky there. That's I wonder. Ideas. Thought components can only be added to actors. Well, I don't think I'm not really adding it to the. I mean, I'm. So Vlad, you can. So audio components are scene components, which mean they could be owned by actors or levels. And but conceptually, you can add it to a U object, no problem. But it could be something funky with. But obviously, I was able to like cache an audio component. So, I mean, you know, I can cache the audio component. That's no problem, right? It's not crashing there. Could be something funky about maps. So let's try to create our own map. We're just working around a problem. This could be a bug that gets fixed in the next version. I really don't know, but we'll work around it because we can do that. We have the power. We don't have to be stopped by this stuff. So I'm going to go to my map and I'm going to break it out. So instead of creating the map here, what we're going to do is we're going to just make this a pair. So we're gonna have a sound base and we're gonna have an audio component reference, and I have to spell that correctly. There we go. Audio component. There we go. So now it's not a map technically, and we're just gonna create an array of them, and we'll just deal with it. It will change some of the functionality. Working with arrays is a little bit different from working with maps. Maps are very handy because they are automatically singleton. But you know what? This is something we can work around. So let's see if that works. Audio. What did I call it? Ambient bed map. It took it. Ha ha! All right, we're making an array. We'll make sure we current map array. There we go. We get what we want. They can't stop us. Old map array. Old map array. Okay. Okay, where were we? All right. Oh goodness, I could have bundled it, the audio component reference in my ambient sound beds. I could have done that. You know, it would have been the same almost in this case. Actually, that's not a bad idea. I'm gonna do that. Let's do that. Let's do that. So I'm gonna instead of using this, since that's where we're at, I'm just gonna add an audio component reference. Audio component, and there we go. And then we've got the fade in, fade out stuff. So you know, when I need to kill it, when I need to get rid of all the old stuff, it'll work. So we just need to change the type. And sound bed type. Ambient sound bed. It's always good to be flexible. And then we can just get rid of this data pair. We don't need it anymore. Okay. All right, so then what we will do is oh, and the other thing that we want to make sure is we don't actually know for sure we look at our check, we don't know for sure that that everything's looping. So we will want to validate the audio component. Because it's possible that they put a one-shot in there, whether on purpose or by accident, it doesn't matter, and it played it, and then it was done, and the audio component cleaned itself up and is no longer relevant. So, in fact, we could even do that as we are dumping. That's actually not a bad idea. So we could validate the AC here and the first step. And that way, we don't even need to put them in the old map. The old map assumes it's still valid. And that way we're just basically cleaning up anything that's no longer relevant. Okay. So it seems disingenuous to call it a map. We will call it a current array. Or ambient bed. That's what we'll call it. Ambient bed array. Okay. So now we're checking to make sure there's anything in this state. If the sound state is empty, what do we want to do? I think right now we'll just say, hey, ambient warning. Because if it's empty, maybe we actually just have that be clear. Like, that reminds me, this could be invalid. So let's validate this first. Validate. Because this object reference, this function could be called with nothing in it. And so if nothing's in it, does that implicitly clear out the state? And I think it might. Let's do this. Put you above. And then this will be very similar. Eventually, all of these print strings we may want to hide behind a debug Boolean or something like that. Ambient sound preset invalid. We'll have to figure out what we want to do there. For now, we will do nothing because that's easier. And we're at the time. We're pretty late. Justin, how you feeling, man?
Good.
Do you need to head out?
Soon-ish.
Okay. The stream's not crazy or anything. There wasn't like a rush or anything like that of people. So, anytime you need to bail, it's totally cool with me.
Okay.
Let's see. Okay, so our first step is to compare and contrast, right? Oh wait, it was to load up our old array. So our old array. If things are if things are in the process of fading out. Fading out creates a kind of a state thing that we have to think about. So if our old array is in the process of, if we have elements on our old array that are in the process of fading out, do we care about keeping their audio component reference, or are we good to clear it out? I think if it's a very long fade out, which should be allowed, then we may want to hold on to it because the GC could hit it before the fade out's done. Aaron's in the chat. Is he still in the chat? Aaron, you still here?
Crickets.
Yeah, well, I mean, there's like a time delay.
Yeah, I know.
Aaron, if you're here, let me know. He might not even know. If an audio component is set to auto destroy, and you have it's in the process of fading out, and you let go of the reference, GC is gonna get it, right? Or is like the state protected because it's on a fade out and it knows that it's going to be stopping? I think for now we may need to mark it because I don't think we can I don't think we can guarantee that it's done fading out, and I don't think we can let go of the reference yet. And we want to keep that reference until it's actually done with itself. So we'll go through and we'll remove any that are invalid. That we know for sure. We want to be able to do that. So let's take our current array and we'll go through for each. I'm just going to build this off to the side. I don't know what order we're going to build everything in. It won't delete the object until it's done playing. While fading out, it still needs to be referenced in memory. Yeah. Even on a really long fade out, yeah. No, that makes sense. That definitely makes sense. So we just want to be able to validate. So is valid our audio component. And if it's not valid, we want to remove the element from the array. So damn it. I don't remember how I don't remember blueprints. If I remove index, remove the item and then give it index with array. I don't remember how friendly blueprints are to this. I may want to actually just walk backward through the array. I'm trying to think. For remove item, what are the other options? Is the actual struct by ref? Do we get a ref for the struct? I think this is a ref. So we could try that. It makes me a little nervous, but I like that better than trying to fudge around with indices. You know, we're in blueprints, so we might as well take advantage of blueprints being super friendly. We'll see if this works. So if it's not valid, we want to remove it. Makes sense. All right. So that would cull our current array. We also want to do this for our old array, but I think at this stage we can move all of our current ones. Actually, maybe what we could do is actually move our current ones to the old array first. Because we'll have to go through the old array to validate any old entries anyway. So instead of looping, through one and then looping through the other one after we've added or before we've added, I think we could just add it to the existing list, clear out the current array, so we've got an empty current, and then clean out the old, get rid of all the invalid audio components in the old array, and then for the incoming stuff, then we'll just be like, hey, and this is where, some of the stuff that I'm doing would be probably cleaner in code, maybe more efficient in code. But the truth is, with these arrays, the kind of stuff that we're doing with these arrays, it's only when we're setting values, and we're only modifying these arrays in this way with really small scales. So, because we're probably not going to have, more than a handful of sounds at any given time. So we should be fairly safe, but it's something to keep in mind that when you're building a system and you're dealing with arrays and you're doing things like, copying arrays over to other arrays, or, sorting through arrays, or, checking all of the elements in arrays, etc. When you're doing that sort of thing, it is definitely heavy work. It's heavy lifting. Yeah, that's a good idea, Aaron. Making a temporary array that's something that only exists inside this function as a local variable, and that can be like the current valid objects. The thing is, we want to make sure that the current array is only representing things that are part of the current preset. The old array is always stuff that is fading out, or we need to fade out if it's not already fading out. Oh, that's interesting. So I think if we call fade out twice, Aaron, if I go is playing, is it going to be is playing? If it's fading out, it's still playing, right? I think it's still playing. So this is where we talk about implicit state and explicit state. So I may want to add some sort of flag which allows me to determine if this is still maybe, since the coroutine running, the fade out still has a reference, it won't get, no, it will hit GC. That's what Aaron was saying. I mean, it won't hit GC as long as it is a reference, but I'm gonna have to hold the reference until it's done playing. So maybe okay, I've got it. We'll just say old. All right, we'll use Aaron's idea of a temp array, and the temp array will be all of the current stuff cached, which could be replaced. And then the old array will only contain audio components that are fading or done fading. And so we'll never double fade. We'll never call double fade. We'll never call fade out twice on an old array, because the old array you can only be in the old array if you're fading or you're dead. So that's basically. And then what we'll do is with the current array, we'll cache it over to a local array, and then we'll clear the current array, and then we'll do our little comparison. Do we keep it do we remove it? And then anything going to the old array is going to be called, we're going to call fade out on as necessary. Good, I like that. So, so just to clarify in our on our whiteboard here, just to make it clear, what we're going to do, because we want to have a very clear idea of, you know, okay, let me just explain the problem real quick for anyone who's sort of confused. So we have this this garbage collector. It's part of Unreal, and it's basically this thing that's like looking around every once in a while. It looks around and says, "Hey, you are you being used? Or are you just sitting around on your lazy butt?" And and anything that's not being referenced equals so the garbage collector is this sort of automatic service that's part of the Unreal Engine, and it's looking around and it's looking at all of the objects, and it's going, hey, is anyone actually referring to you right now? And if there's no reference, then it thinks, oh, well, no one's using you, so let's toss you, and let's clear up that memory. And so in our situation, we have a couple of states, right? We have playing, we have fading out. We would consider playing and fading in as part of the same state. Fading out was the states for audio components. Fading out, and then there's done, right? And on an audio component, it's auto destroyed, which means when it's done fading out, it's automatically going to clean itself up. It's no longer going to be a valid audio component, and that can be useful for us. You know, if we wanted to pool it and keep reusing them, we wouldn't want that, right? But we'd still want to know the state. We still want to know if it was done. So either way we go, we still want to know it's done. What we want to make sure is that these states are very clear. This one's easy to check. No audio component equals done. Now, for fading out, that's a little bit more ambiguous because from the system's perspective, it's still playing. Inside, under the hood, it's like, oh, this is a playing sound. If you have a playing sound with no ref, just like any other object in the Unreal Engine, the garbage collector is going to think it's good to throw it away. Now, it's possible that you have sounds to which you don't have references that, like Aaron said, it won't delete the object until it's done playing, but fading out still needs to be referenced in memory, right? And so, you know, there's ways to play sounds without having to deal with references, right? But anytime we're dealing with the audio component, we want to make sure we hold on to that audio component to prevent it from being thrown away. And so we'll say that for this case, this will be our old array. And the only way you get into the old array is by getting faded, is by getting faded out. Is by calling fade out on that on that audio component. Then it goes to the old array. So we can assume if it's in the old array, it's either fading out or it's done. And then this will be the current. And then we'll use an intermediary array for our shuffling. So we'll dump the current into our intermediary array. And then we will do our check where we have, is this new, or kept? And then it'll go back into current, or a new one will be added to current. And anything left over gets fade out, and then old array. Cool. Does that make sense for everyone? Any questions about all that logic? It's a good time for me to take a drink of water. Oh my god. All right. So, we're going to promote this to a local variable. We're going to call this our local ambient bed array. Okay. And then, so we're going to set. I hate to throw another thing on the stack. You can use get play state to return an enum. Is that part of 425? I forgot. I know that's something that you added recently. I guess I could just look. Ah, you're right. No, I can't. Yeah, what are the states? All right. Oh, it works on 424. That's great. Well, that's real handy. Uh-oh, I've got some sort of ping. Stream seems to be fine. I don't know what that ping was. All right, so he did add that to the stack. It's good to know that. Do we want to use it? I mean, we've already figured out our states. It's a good check, though. But, yeah, you know what? I'm not going to use this, and I'll tell you why. Because if the audio is paused, it's not going to say if it's fading out or playing. All right, Joey. I'm glad you could join us. Drive safe. I hope you have a good rest of your weekend. Yeah, so I'm not going to use the play state because in some ways I don't care. I mean, obviously I do care because I'm thinking about it. This is very explicit state, which is nice. But if it's fading out and it's paused, like paused is not helpful. If it's paused, I'm going to have to rely on this the way that I'm thinking about state right now anyway. So I'm going to continue thinking about state the way I am. But it's good to know that this is here. This is super helpful. Thanks, Aaron. Okay. Where was I? Right. So we're caching it over. And then for the future streams, if you're up doing it. Yeah, I mean, I might do other ones. It depends on how well this is received in the long term, and also if my voice can handle it. Oh my god. It's been a long time since I've lectured for 3 hours straight. Okay. All right. So I'm going to take my current array, caching it over to the local bed, and then I'm clearing out the current array. So the current array is now an empty slate. And then I've got my incoming array. And I might... Let's cache this. So I'm going to cache incoming. I don't know if I need to actually cache it, but I think I'd rather that. Ambient bed array. This is just a local variable. And it's just a way to more conveniently access this data. Otherwise, I'd have to access the preset in and then pull it off like this every time. And it's not like I can't do that, but this is a data asset reference, and the thing you have to appreciate is that data asset references, the data on data asset references, serialize right into the data asset. So you got to be careful with data asset references while you're working in the editor. Outside of the editor, you know, it's not going to serialize into that data asset. Hopefully, I don't think it will. You know, so you will probably do things. You know, it's just a layer of protection, I guess. That's how I put it. So I've got an incoming array, and now we just want to add the right. So we'll add the incoming array to the current. So get current append, and that'll be the incoming array. And the incoming array we will want to fade in according to their individual data. So we may actually, before we do this, actually, here's what we'll do. Is we will for each our incoming array, because we want, when we add it to the current, oh, no, wait, hold on a second. Because what we want to make sure is we want to make sure that we're not adding, because add unique is not going to help us, because our data bundle, what we don't want is we don't want two audio components playing the same sound, right? So what we're going to do is we're going to add each sound individually, but we're going to check it against our local array. And then we'll pick which one to add. And then we just need to make sure that if we add it from the local array, that the local array is getting that element is getting pulled out. Because if there is an existing audio component, we want to make sure we keep that audio component and it's still playing the sound. So, so we're going to loop through the incoming, and then we're going to for each, and this is a little bit, like I said, this would be painful with a large arrays, but I think we can get away with this logic on short arrays, because we're really talking about, you know, a small handful of elements. So what I'm going to do is every time on every element of the incoming array, I'm going to loop through the local array, and then I'm going to compare sound base references. The local array is going to be comprised of all. Actually, let's go up here. The local array is going to be comprised of all currently playing sounds. So equals. So we just want to check our references. Branch. However, we will want to. We will probably want to take the income. This is an interesting choice, and maybe this was a sort of fault of mine in terms of fade in, fade out. Bundling the fade in, fade out means that the fade time values are going to be linked to the preset. And so the question becomes, the new preset fade values should be adhered to instead of the old preset fade values. So we're going to take the old audio component, but we're going to take the new fade values. So if these are equal, then we want to take the current array, and I suppose we could do add unique, but I don't know. I mean, it's going to be like a composition. So we're going to be adding the sound reference and the audio component reference of the old one, but the fade values of the new one. Whoops. Because this is the preset we want to use now. This is what we're really comparing against. Maybe I'll switch this. Okay. So so here we compare the incoming with the old, and we should validate this. Is valid. And if it's valid, then yes, absolutely. If it's not valid, then we we're going to do something very similar. In fact, what we'll probably do is let's just make this. Let's do this. No, that's not what I wanted to do. I wanted to promote this. So let's do a promote local variable, and well, this will be our new incoming ambient bed. So if it's valid, then this is this going to be this? This is what I've made before. And then if it's invalid, then we need to make a new one. And the new one can just be the new preset. Which this is gonna be a little blueprint spaghetti here. Let's do. Let's do this. So we'll just set it early here. And then we can reference this right off. That helps clean up the spaghetti a little bit. And then if it's new, if the audio component's valid, then obviously we'll want to keep we want to add it as we did before. If the audio component's invalid, if it's not valid, then we can assume the sound has stopped, and so instead we're going to need to add the new one, but we'll just actually just play it. This is begin our fade in, so we'll break here. If it's invalid, we can assume it's stopped, and we need to add a new one. So we'll do a fade in. Wait, whoops. What am I thinking? Spawn sound attached. And this component that we attach to, or the object that we attach to, scene component object reference. We may want to, let's see. First, we're going to do this. And then, oh, I guess this will be where we set the new. So let's do a fade in, and the fade in time is going to be there. And then this audio component will be part of the new set. Is it going to make me... can I actually just get the audio component? Audio? No. Set members. No. Oh, blueprints. Okay, so we will do this. Like this. This. It's a little bit messy. Okay. Now it's fading in. And now we can add it to our current array. Okay. If it's not equal, then it is basically a new sound, and we want to spawn a new sound anyway. So there you go. Right? Or actually, actually only if we've completed. So if we've completed if we've completed our loop and we have not located it, then it is a new sound. So we'll treat it as a new sound. So then we will, but we will need some sort of flag to let us know. So I'm going to do sound added. And so at the beginning of our loop, or before our loop, we will set that to false. I hate these flags. These flags make me think that I'm doing something overly complicated in a way that could be simplified. Okay. All right. So we'll branch. Right. If we have added a sound, we will add this to true. And so if we've completed our loop and it's still false, then we will add a sound. And then I think we can actually do this, get it not I like to think in the affirmative. So in this case, I'm checking if it has not been added. If it has not been added, then we spawn a new sound. There we go. So that's only when the loop. So this is where we want to add some maybe comments, because we're like, this is getting a little messy. So here we'll just say, okay. Very good. Boom. All right. Then it goes back, it loops through, it sets the new one, boom. It sets the new incoming, boom, okay, check, and then what is this? If it doesn't match, then we say, forget about it, skip to the next one. If it does match, we go through, check the audio component is still valid, great. Then we just set the new audio component, we just transfer over the new fade values, and then we add this back in, and we say, hey, that sound was added, you don't need to create a new sound. And if the audio component is not valid, we assume it's been stopped. We have to create a new sound. I mean, I guess at that stage, I guess I didn't really need to do this branch. Because if it's stopped, then we create a new sound anyway. I guess I could, if it's stopped, where is it, a local ambient bed array? If it's stopped, then that's probably a good opportunity to just call it from that array. So maybe instead of doing this, and just to make this a little cleaner looking, we'll just duplicate this. We don't really need that part. So this will go here instead. And so if it's invalid, then we just need to remove that entry from the local ambient bed array. Right, we're checking the local ambient bed array. Yes. Valid, invalid. Remove. Item. Okay. All right. So that we assume that it's been stopped, and we just need to remove the item, because we'd have to create it new anyway, which is what happens down here. So here, we have not added a new sound. Now we add it. We add the new sound. Boom. We generate a new audio component. We say faded. We call faded on the same execution. And then we can have this be a part of the input. So there we go. So we have something to put here if we need to. Get component attachment. And that way the API can feed in a component. Okay. So if the incoming sound was added, then we skip this part. We don't need to create a new one because it already exists. Cool. Okay. So that takes us through all of the new stuff. This covers add and keep. for remove, I probably should have done this the other way around. Because if my big loop is the local array and the small loop is the incoming, then when I get to the end, I will know I need to remove it. Yeah. So this is going to get a little interesting. Let's swap this out. I'm going to put this at the beginning of this array. And then I'm going to swap these. Should be good. And then the only thing I need to make sure of is we'll have to do a little swappity swap. Let's do this. Old array candidate. Ambient bed candidate. I hate this. But it's getting the spaghetti is getting unwieldy, so I need to cache this. All right. So we got the new and the old. So the old goes here. The old goes here. Okay, let's just make sure this logic still works. We've got 9 viewers. People are dropping like flies. They're like, arrays. We are 4 hours in. It's pretty intense. Okay. All right, let's make sure this still works. A local ambient bed array. All right, so we cache the first element. We set, hey, we have not added a sound yet. Then we go through the incoming, and we cache that element as we loop through each one, and then we compare them. The old versus the new. Are the ambient sound references equal? If they're equal, is the old audio component reference still valid? If it's valid, then let's just set the new settings with just the new fade-in settings, and we'll keep the old sound reference and the old audio component reference, and that will become our new unique current sound. We don't have to do anything because it's already playing, or we assume that it's already playing. And then if it's not valid, then we just remove the old bed candidate from the local ambient bed array. We assume it's stopped playing and we no longer need to hold a reference to it. If, however, we loop through all of them and we have not located the sound, then we need to fade out. So then we need to fade out. Now this old reference candidate has become an actual old. It's an old. So we will call fade out. Hoping you would hit some snags so we could see some real ass troubleshooting. All right, All right, Arthur. I'm really glad you could join us. I know it's late in the Eurozone. I hope it was enjoyable for you. um, all right, cool. There we go. We're fading out, and then now that our state is fade out, we can add unique to the old ambient. Add unique. Boom. Okay. We can get rid of this old sketch there. All right. So, super enjoyable. Thank you, Arthur. Appreciate that. Local ambient bed array. So we've cached the local ambient bed array, then we clear the current ambient bed array. What we haven't done is culled the old ambient bed array. And we could do that before this. Why not? So let's just get this out of the way. We're going to do 4 each, and all we're looking for is them stopped or invalid audio components. Assuming auto destroy. If you'll notice, auto destroy is checked on. We must have auto destroy on. That's the expectation here. The functionality depends on that. Otherwise, I'm just going to have audio components everywhere. Okay. So we're going to check is valid. Boom. And if it's not valid, we just want to remove it. Simple. Right. Oh. Remove. And, you know, if it is valid, we're not going to do anything. We don't care. That's fine. Excuse me. Okay, so we'll do this. Put a little comment around this. Cull out invalid audio components from old array. I'm going to make this orange. And then when we're done with that, then we will do this. Do real quick. Oops. Clear current cache. Then clear current array. And then loop through cached array, looking for dupes on incoming array. Then we get to this branch if dupe detected. So we just add it back to the current array. We get here if the audio component is AC invalid. Sound must have stopped. So remove. And we'll make this orange as well. So we can see that this will be green. If it has not been added, add it. Otherwise, was not detected. So fade out. Is this still true? Incoming sound added, not added. So, oops, that's bad language. So we'll say no dupe detected. Add new sound if not yet added. I have to double check that logic, make sure that makes sense. Yeah, let me just double check that. This is why you comment things. Okay. So the local ambient bed array, boom, the old array, or old array bed candidate. Incoming bed array candidate. Incoming sound added. Incoming sound was not yet added. So we get here if we have not hit this spot. I think we need to get there. I think, let's see, not equal. This logic is no longer, because we swapped the big and little array, this logic is no longer what this says. Because unique, if they're not equal, doesn't mean that they don't exist. It just means we have potential ones that haven't been added. So I could add a, I could say sound added. All right, let's work this out loud. Oh my goodness. All right. Can I do it like this? Okay. All right, so old candidates. Loop through old candidates. And then we loop incoming. Found. So basically I need to say whether or not an incoming one was found in the old list. So I need to check both situations. Because right now all I'm doing is looking to see if this exists in here. But I need to mark that nothing was found. I need to be able to say, hey, we've gone through this loop. Oh, that's really annoying. I kind of want to, I have a case for both situations. That's very frustrating. Because I don't want to, I'm trying to avoid looping through stuff over and over and over again. And I feel like this is just a logic puzzle. But loop, like if I loop, I can loop through the old candidates and compare them to every incoming. And that will tell me if I need to keep or if I need to, if I didn't find it. If I didn't find... If I go through all of them... Ah, this is what I got to do. I have to remove it. So if I find a dupe, I have to remove it from both. Ah, there we go. That's what we want. So dupe, if I find a dupe between the two, then it gets removed from both lists. I remove from both lists. I remove it from both lists, and then what I get is a list of new and a list of old. There we go. So there we go. That's what I was missing. Okay. Okay, so so dupe is detected. Now, if I modify the array while I'm walking through it, is Blueprint going to protect against that? Oh my goodness. Okay. So if I've added it, then it can get removed from both lists after I've completed it. And then what's going to happen is we'll deal with this later. So this will be our removal. This is our old list, right? These are all going to get sent over to the old list. And our new ones, so if it's not, if we go through, hold on, I don't know if we want to do this. We want, boop, boop, boop. When if we haven't added the sound yet, then we're not doing this, because that's no longer the context. This is like this. So these are the two sides of the coin, right? This is our new. So let's add this new. Oh, I guess our Zoom meeting was ended. Justin must have left. Okay. So this is adding new. Adding new. Make this green. Fading out. This sort of warning yellow. Okay, so if we go through all the incoming ambient bed stuff and we have not found a duplicate, that's great. However, if we did find a duplicate, yeah. So, all right, we're gonna create a ambient beds to remove. Oops. Because every time we go through this list and we add a new one to the incoming, we want to remove, or to the current, we want to then remove that from our working arrays, basically. We want to take them out, but we don't want to do that while we're looping through the array. So we're going to do it afterward. So we're going to create a little list of add unique. Because we don't want to keep track of the currents anymore. We want to have our list basically be only new and only olds. That's what we're looking for. So our new incoming ambient bed. And the problem is this reference is a newly created local reference. So it could be a composite. Yeah. So I'm going to have to do it by the ambient sound. So this is why if I could have made a map, it would have been a little bit easier. I have to deal with these arrays, which means I'm always breaking the data out and then comparing stuff. But that's all right. We'll live. We will live. So here I'm adding to the list. This sound was added. Boom. It must be removed. And then likewise, I could probably, I mean, it is getting removed from the local ambient bed array. I'm going to assume the incoming obviously doesn't have any audio components, so there would be no reason for that to be, that's not relevant. Okay. So then what happens is we get to the end of this loop. And do we care about this? Was hit? If we don't hit this, if we didn't add any sounds, yeah. So if we'll say if sounds were added, so I'll take this not out. So in this loop, Duke detected, or it's not really, sound added, remove from working arrays. And that's the inner loop. So we only want to cull from the incoming array bed. Or actually, I've added it to the current, so it can be from both. Yes, so we want to cull it from both. So then we'll say get for each we've added a sound. And we want to remove it from the local and the incoming. From both. But the incoming's reference is going to be different. This is... There must be no way... Man, this map... I really wish we had a map. Okay. Because I'm going to have to go looping through each one. Breaking it out. This is going in circles. Because at this stage, I'm still working with the array. I mean, it's possible Blueprints is not going to get... I mean, I don't remember how Blueprints... If that's something that we could get in trouble for with Blueprints. Blueprints has some protections. The thing that I'm worried about is looping through an array and then accidentally grabbing an invalid element. That's what I'm worried about. That's all. But Blueprints has a bunch of fuzzy bumpers on it that let you get away with a little more than you would if you were coding this. And I'm trying to remember if this is one of them. But anyway, what I want to do is I want to remove this. Let's fucking go for it, see what happens. I mean, at that stage, maybe why don't I just do it up here? I'm looping through it. There's no reason to cache it. I am removing it here. So let's say, let's just go for it. Let's see what happens when we remove it as we go. It could be trouble. Oh wait, we don't want to remove it yet here, right? No, wait, we do. Yeah, this sound was added. As soon as added, we can remove it. Remove it from both lists. Yeah. So let's do that. Oh man, this is gonna be crazy. Okay. All right, so we want to remove it from remove item. And the local, it's going to be the old. And then the incoming, remove item, is going to be the new. So we'll see if I can get away with that. Okay, and then we'll comment this. We'll say item no longer needed in working arrays. Make this red because it scares me. All right. Okay, so now we're removing it as we go, as we find sounds. If we get to the end and we have not found an appropriate sound, do we care at this stage? I'm trying to think. We might not care. We might not care. Because that was part of the old logic. So let's just walk through this real quick. We've got our local cached array of old candidates. We go, hey, this might be an old candidate. Then we loop through the incoming and we say, hey, any duplicates? If we find a duplicate, we move it over to the current set, and then we remove it from the old lists. If we didn't find a duplicate, then we keep looking. We skip to the next one, next one, next one, next one. We go through the list. Boom. Then, when we're done with the list, we go to the next item and we compare that and we go through them all. And I think as long as we're moving on the way, we don't need this. And that means we don't probably need to keep track of this state. So I will eliminate those for now just to keep this cleaner. And let's see if that bites us in the butt later on. So presumably at this stage we have Now a list of new and a list of old. And the list of new is going to be, we're going to want to do this too, right? So let's do a list of new is going to be all the incoming for each. And then this is going to be this. I don't think I have any other references in there. That's fine. Adding new. Okay. And then there we go. That looks nice. Relatively speaking. Let's make this bigger. And then for the olds, for each. We will fade it out. And then for the, let's just double check this logic real quick before I dig too far in. Okay, so we've gone through, we've looked for all the dupes. Whenever we find a dupe, we remove it from the other two lists. We add it to the thing and we'll go to our current set and we're good to go. Then when we're done looking through all of the dupes, we go and we say, okay, we have whatever's left on our incoming array, that's our news. And we add them. Yeah, that's fine. We can do that. And then we reuse this variable. That's fine. That's totally cool. Spawn it, auto destroy. We fade in with the appropriate fade values, and then we add it to our current list. Then we go through the old list, and we say, okay, these are all supposed to be faded out. So we set fade out on them, and then we add it. Wait, this, whoops, sorry. This should be a straight reference. That's fine. Cool. Very nice. Then, okay. Now we have some logic. And this will go up right at the top. Boom, right there. All right. Look at this. Where are we at? Almost 5 o'clock. Now let's see if it works. Now let's see if it works. Oh my goodness. All right. So let's go to our old audio sublevel. Now we're going to we're going to keep this logic around. We're not going to use it, but we still want to hold on to our volume. So I'm just going to cut this and go paste it over here. It's like old code. And we're not going to worry about ending overlaps right now. So we're gonna skip those. We don't care about those, but we will do this. Here's our little game instance call, and then we set ambient sound state, and we will give it. This was supposed to be our forest, right? Forest volume. The forest crash. Crash. Well, it's been a while since our crash, so our last crash, so we were due. Okay. Yeah. I like data assets, but I've noticed that um, sometimes data assets are a little crashy if you've got them open at the same time as you're using them. Set state. Set ambient sound state. And we will see. Look at that. Well, now we're fine. And then let's give it an object. I wonder if I can give it the forest audio component as not the audio component, the forest volume as its component. Why not? Let's see what happens. Could be fine. Let's see. Is that get root component? There we go. I don't know if that's important. It's probably not that important, but yeah, why not? All right, and then everything else is basically the same for the mountain, except we want to have the other preset, and we want the other volume referenced. Okay. All right, and hopefully this will all work. Okay, ambient manager initialized. We walk over. Look at that. Stat sounds. We've got our forest. We've got our mountain air. Yay, we have a system. All right, so let's prove out something real quick, because one of the features that this system supports is multiple beds at once. So let's see if I can. Let's see if I got another loop in here. Here's what I'll do. This will be interesting. So I will create a sound cue that will be our mountain winds. And I will grab our wind gusts. And let's do random. And we can look at these. We can look at the columns on these and just get a sense of the duration. You can see these are straight out of my sound library. So they're all about 9-10 seconds long. So we'll go back to the tile view. And what we'll do is we'll try to set up a looping. The looping cue is basically a retrigger. And then we will do a delay of, let's say, 8 to 16 seconds. And then it will randomly select one of these wind gusts. If I play it, oops, what am I missing? Oops. I'm not auditioning this. Something missing with this? There's our node. There's our random. Oh, right, of course. The delay is probably the start time as well. So I'll have to wait. Wait on that one. Let's see. 8 seconds to 16 seconds. There it is. It's quite loud, so I might, I might mix this a little bit lower, like 0.25. So I'm just gonna hit play, and it's gonna play, and I'm just gonna wait my long time. I could almost bring it down like a significant amount more, actually. Let's do let's do 0625. Sorry, I like subtle ambient sounds. Huh? We wait our 15 seconds or whatever. There we go. That's what I'm looking for. It's just supposed to sit right on top of that mountain air. Okay, so then on our mountain preset, we will add this as another member. Boom. See, now we're in the fun part. This is like the design part. We've made the system, right? And now we can just have fun with it. And you know, this is also proving the feature works. So hopefully it does. But yeah. So here, and then we could do fade out. Let's do a long fade out. So these can have separate fade outs, which is kind of cool. So now I play, and we'll solve the issue where the character spawns inside the volume, but let's just get this mountain air and just see if the other elements start to play. There's our wind. Nice. So I could bring the mountain air. I'm starting to design a little bit. I probably shouldn't. But let's just bring that down. It's such a small thing. I just want to have that a little bit. Okay. Let's hear that. Let's hear the gusts on top of that adjusted air level. I might bring it down even more. That's real subtle. But it creates a variation to that backdrop, which is kind of nice. And another one? We'll have to see if another one. The timing of those could be different, right? You could make the delay shorter. There's another one. Yeah. Okay, so now we have so this is a good stopping point. I think, we've got for about 5 hours. It's what I want to stress is that this is not disposable work. This is, you have now created a system, and that's something that you can port from project to project. It's something that you can reuse, and it's something that you can continue to add features to. This is the thing I want to stress. This is about you creating systems that work the way that you design sound, and the way that you think about composing soundscapes. So that's kind of the crux of this. And when you have that under your belt, then you can go and take it to. I mean, this is so general purpose right now, right? We just have a simple blueprint function that we call set ambient sound state or whatever, right? We have a preset which is very easy for designers to use, right? It's just this. The functionality is so basic that adding stuff like it's just the sky's the limit as far as what you could add to something like this, right? You could think of ways of like modulating sounds. You could do crossfading based on location or distance from certain things inside this. It's no end to features that you could create, and so that's really what I hope that the takeaway for you is that this is not just a system that you build every single time you start a project. This is something that you have made an investment in, and you spent 5 hours right now making something that works, carries the basic functionality you want it to have, and you can just start playing around with it, right? But every time you add to it is more of an investment that you've made in that system, and you can just keep taking that system as long as you think about general use cases, as long as you think about like, hey, how can I make this, how can I, like, because there's always going to be some specific problem you're solving, but if you pull back and you ask yourself, how can we solve this problem from a general perspective, then I think that you'll have something really valuable in your pocket. And if you're a freelancer, working from indie game to indie game, these are tools that are part of the value that you bring to a project. And if you're in-house, this is something that the whole team owns, and you can constantly add value to. So yeah, I hope that hope this was useful. If you're catching this stream after the fact and you want to ask questions, feel free to hit up the chat, or not the chat, the comment section under the video. But also check out our Discord, the unofficial, like, what's it called, Unreal Slackers Discord is a very cool place. Lots of cool people on there. And then also, hit up the Unreal forums if you've got some sort of more official question. This is a very unofficial stream. So it was just something that I wanted to get out there. I know people have asked me, like, how do you build something like this? And there's no right way to build. I mean, there's no wrong way really to build it, except if it doesn't work. And sometimes the way that you think you're going to build it, like today, it didn't work out for one reason or another. And there's always a process of discovery when you're building stuff like this. But yeah, anyway, yeah, I'm spiraling out. Anyway, it's been 4 hours. So yeah, Aaron, yeah, thank you. I appreciate it. Yeah, I think that we could do this again. I'll probably want a break in between, a serious break in between, but it would be fun to do something like this again. Dan, thank you for coming by. Yeah, I would be interested in doing some more. I definitely think it's really comes down to, like, because I like the build from scratch kind of stuff, and I think it's really comes down to, like, what could I build in an afternoon? That's what it really comes down to. And sometimes I worry, I mean, if this archives well, I hope it archives well, but sometimes I worry that, like, I go too fast. Because I work in Unreal all the time, and so I know that I tend to go faster than when I first started out with Unreal. So hopefully the video stream as an archive will be a useful resource for people. But yeah, it really comes down to, what do I think I could build in an afternoon. And that's not everything. Some things actually take time, but those, like I said, those kinds of systems, even on their own, even if they take you a week to build, have value because they're things that you then own and you can continue to use and reuse and repurpose. So yeah, I'm glad it was useful for people. All right, I am going to head out, and I will play some outro tunes. Thank you everyone for joining. I really appreciate it. All right.